Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about graphing using XY tables. In this presentation, you'll learn how to create an XY table. You'll also learn how to use an XY table to graph a function. What is meant by the statement that the ordered pair 2, 4 is a solution to the equation 2x plus y equals 8? Well, we've talked about solutions to equations and inequalities in previous presentations, and it means the same thing. It means that when x is 2 and when y is 4, that equation is true. The ordered pair 2, 8 is not a solution, and again, it means the same thing as we've said previously about solutions. If you let x equal 2 and y equal 8, you do not get a true statement. So 2, 8 is not a solution. Let's take a look at the ordered pair 6, 4 and the equation y equals x squared minus 5x minus 2. Is this a solution to the equation? Well, if we let x equal 6 and y equal 4, we would have 4 equals 6 squared minus 5 times 6 minus 2. And just cleaning up this expression here, we would finally get 4. And that is a true statement. 4 is equal to 4. So we would determine that 6, 4 is a solution. Let's show that the ordered pair 2, 0 is not a solution to the equation y equals x squared minus 5x minus 2. Well, again, we'll let y equal 0, and we'll let x equal 2. When we do that, we get the statement 0 is equal to 2 squared minus 5 times 2 minus 2. Cleaning this right-hand side up, we finally get negative 8. So we get this statement 0 is equal to negative 8, which is not a true statement, it's false. And so the ordered pair 2, 0 cannot be a solution to that equation. So this presentation is all about graphing, so it makes sense to ask, so what is it that we're doing when we graph an equation? Well, what we're really doing is we're putting all of those solutions on the XY plane. We're visually representing where those solutions are located on the XY plane. So this makes a very important connection between when we say that an ordered pair is a solution to our equation and the fact that it will appear on the graph, and also the fact that it makes the equation say a true statement. Those three are always going to happen when we talk about solutions to equations. We'll have all three of those in one. And that's what makes using an XY table to graph such an efficient method. An XY table is simply just a table that helps us organize ourselves to find ordered pairs that are solutions. And so again, we have the ordered pair, we find that they are solutions, and then we know we can plot them on the graph and that they will be on the graph of our equation or function that we're graphing. One caveat to using this method is that we are only using a finite number of ordered pairs. So it's really important that we keep making solutions, we keep finding solutions to plot on our XY plane until we know what the graph is supposed to look like. Okay, maybe it's a line, maybe it's shaped like a parabola, etc. But stop when you know what the graph looks like from your ordered pairs. Another helpful thing as we begin graphing will be to know what certain equations and their graphs look like. So I would recommend that you pause this presentation now and graph the following functions, either in a graphing calculator or go to Wolfram Alpha and graph these, just so that you can get a look for those equations and how their graphs look. These are actually representatives of any equation that looks like these, even if they have some slight variations. Anything that is an x squared as its highest exponent will have the same shape. And so these are nice representatives of our graphs. All right, let's make some xy tables and use them to graph. Consider the function f of x equals negative 3x plus 1. And again, we're going to just organize ourselves in this xy table, and we're going to find solutions. And so what we generally do is we'll start by picking some x values. And here in this presentation, you already see my completed table. But if we were doing this and you could see it in real time, you would just see, to begin, just the x's in here. And then what we would do is we would take that x value and we would plug it into our function to find f of negative 2, for example. Excuse me. And when we do that, we get 7. And so this is telling us that the ordered pair negative 2, 7 is a solution to our equation. It makes the equation true. And it should be an ordered pair that our graph passes through. And then we would do that again with negative 1, and we would do it with 0, and with 1, and with 2, so on, until we've made a handful of ordered pairs that we know are solutions. Then we can plot those solutions on the xy plane. And again, if we plot them and then we don't know what the shape of the graph is, we might make some more. But here, after plotting those points, it becomes pretty clear that this is a line, and so we can connect those ordered pairs, and we have our graph. So take a look at a second example. We have the function x minus 3 raised to the 1/2 power. And this is the 1/2 power is the same thing as square root of x, or in this square root of x minus 3. And I will use the shorthand SQRT for square root in this PowerPoint. All right. We'll make an XY table to graph this. We'll start by picking values for x and plugging them in. And some functions need some special consideration for what x values to use. So let's just try 0 to start. If we try x equals 0, then we plug in, we find f of 0 is the square root of 0 minus 3. So it's the square root of negative 3. But there's a problem there. The square root of negative 3 doesn't exist in the real numbers. Okay, it's not a real number. And so we're only dealing with real numbers in this course. And so we would say there's no solution here. There's no y value that corresponds to an x value, 0. So 0 is not in the domain of f of x. And there are actually others that are not in the domain of f of x. Let's check out x equals 1 and see what happens there. Well, when x equals 1, we would have the square root of negative 2. That's also not a real number. So we can't use x equals 1. All right, so what numbers can we use? How can we know where to start making our xy table for this square root function? Well, square roots, you can only take the square root of numbers greater than or equal to 0. And so we need, in this case, we're taking the square root of x minus 3. And so we need x minus 3 to be greater than or equal to 0. This means that we can only use x values that are 3 and greater. Okay, 3 and greater. And so when we make our xy table, we'll start with 3. And we'll choose some x values that are greater. I chose some x values that make make the square roots turn out nice.